So video 4 of 3, I forgot to include the comments on the code, so I'll quickly run through how the computations work. Initially we set up our libraries and include them in our code so that we don't have to set up communication between our devices. We have our sensor, our servo. We then go to our definition of gyroscales, which I'll go into a little bit later, and then we set our PID values. I'll also go into a little bit later. We initialize our variables, set them to floats, unsigned longs, floats as required. Here we have our servo object that we create. We then go into our setup where we begin our baud rate. 38400 is applicable to this application. The transfer rate is recommended. We initialize our sensor, get our gyro sensitivity. We then attach it to pin 9 on the microprocessor. We go through a testing connection process where we test connection between the microprocessor and the MPU 6050 and also the servo. If it's successful, it displays as such, and if it's unsuccessful, it also displays as such to the serial monitor. We then move into a calibration process where we go through 500 iterations for the sensor. It gets 500 values, divides it by the average, and it subtracts that from subsequent values. Because they're so sensitive, it's required. By making it part of the for loop, you don't need to do it every single time, it just does it itself. Moving into the for loop, we start with a Miller's function, which we use for further computations because we needed to t the change in time for integration as well as derivative calculations. We start with an if statement because question 1a requires us to move it to one position and then another. So if we start with a initial position, we go through getting the value. Here we get that value, and because that value is in least significant bits, lbs per second, we need to convert that by applying it to that gyro scale, which is up in the like we talked about in the initial part of the video. By doing that, it converts it to an angle velocity, and by integrating that angle velocity we can find out the actual angle because we've got the change in time which we initialized with the Miller's function. We then set a point where we want to move to. I used negative 20 degrees. I know the assignment said 5, but just to get a little bit further movement with the model, I couldn't really notice 5 very well, so I just increased the angles. We then set an error, which is just the error between what is the set point and what the feedback is. So we go through our PID calculations, we map that to the actual servo, and then we print the outcome to the serial monitor so that we can debug as required. This next if statement then goes to the second movement of the model, moving it to 10 degrees. So again, it's not what the assignment asked, but it was just to get that little bit more movement out of the model so it was a bit more noticeable during the video. The rest of the code is much the same, using the same calculations, displaying the same messages to the serial monitor. Here we have just ending the Miller's function and getting our change in time, which is just the start time minus end time. For question 1b, it was much the same. I just removed the if statement and set the value to what I wanted, which was, I still went through the calibration process, and then set the value to 20, minus 20, and then I moved the base around as is shown in video 3. Okay, thank you very much.